I'm going to go over the free response review questions for our Unit 6 test over the applications of integration. So here we go. Number one, we've got two functions. I'm going to focus first on this figure 1, where it's looking at the shaded region labeled R, and it's asking us in part A to find the area of that shaded region. So when you're asked to find the area, and in this case, we're looking at these functions from like a top function to a bottom function, we're going to be doing the integral of the top function minus the bottom function. So in this case, my area is going to be equal to the integral from 0 to 1, right? Because the x, when I look at my x values here, that's x value of 0 all the way to x value of 1. And then I'm doing the top function, which is g of x, so negative 3x squared plus 7 minus the bottom function f of x, which is e to the power of x minus 2, right? And I always make sure I have my notation, d of x, all right? So if I clean that up a little bit, the integral from 0 to 1, I don't have any other like terms with negative 3x squared. 7 minus a negative 2 is really 7 plus 2, which is 9. And subtracting e to the power of x is going to be minus e to the power of x. So I'm going to do the antiderivative of this, which is going to give us, all right, x cubed. If I took the derivative of x cubed, I would get positive 3x squared, but I do want a negative, so I'm going to put a negative in front. The antiderivative of 9 is 9x, and the antiderivative of e to the power of x is e to the power of x. Okay, so this is my antiderivative, which I'll be evaluating at 1 and 0. So if I plug in 1, that's the opposite of 1 cubed plus 9 times 1 minus e to the first power, all of that, and then minus, when I plug in 0, I get the opposite of 0 cubed plus 9 times 0 minus e to the power of 0. All right, so let's simplify the left side. 1 cubed is 1, but the opposite of that is negative 1 plus 9 minus e. And then subtracting here, that's going to be 0 cubed, which is 0. 9 times 0 is 0. That's all 0. But I do have a minus e to the 0 power, which is minus 1. And subtracting a negative 1 is actually going to be adding 1. So negative 1 plus 9 is 8. 8 plus 1 is 9. So you could write this as 9 minus e, or you could write it as the opposite of e plus 9. Either one of those would be correct for the area of the shaded region R. Okay, let's do letter B. Now, letter B says to write, but do not evaluate, an integral expression that gives the volume of the solid generated when R is rotated about a horizontal line y equals 8. So if I were to sketch in figure 1, right, it'd be like up here. If this right here is y equals 8, and I were to revolve this shaded region R about that axis, about that y equals 8 to get a shape, I would notice that there is a gap. So when I think of answering this question, right, I'm thinking the work we've done with the washer method, and that's where I focused on calculating a capital R and a lowercase r. All right, so the capital R, remember from your practice in Delta Math, is the distance from your axis to the farther function. So when I look at my functions here, the farther away function from y equals 8 is actually the f of x function. So my capital R is going to be 8 minus, and the f of x function, which is e to the power of x, minus 2. My lowercase r is going to be 8 minus the closer function, which is g of x, which is negative 3x squared plus 7. You can go ahead and clean that up if you want for both of those. When I subtract e to the x, I get e to the power, or the opposite of e to the power of x. 8 minus a negative 2 is actually 8 plus 2, which is 10. And then let's see, this will be the opposite of negative 3x squared, which is 3x squared, and 8 minus 7, which is 1. So when I do my volume, I have pi out in front. The integral is still going to be from 0 to 1, right? We're revolving around a horizontal line. All right, so 0 to 1, but I'm going to have my capital R squared. So I'm going to put the opposite of e to the power of x plus 10, all of that squared, minus my lowercase r, which is 3x squared plus 1 squared. And then don't forget, you don't want to get points off for this, to put that dx. All right, so that is the answer for part B. This is the integral that I would solve if I was trying to find the volume of that solid generated when you revolve or rotate r about the line y equals 8. Okay, part C. All right, so part C, we're moving to region S, so we haven't done anything with figure 2 yet. And it wants to figure out the volume of a solid if we're looking at each cross-section perpendicular to the y-axis is a rectangle with height 5 and base is region S. So it's hard to kind of show you, but I'll try to zoom in for you. Use a different color. So the idea is perpendicular to the y-axis means that when I draw a rectangle, it's going to be like this. And what you're going to learn from the practice that we'll do with multiple choice is you want to think about finding the area of those cross-sections. And the area of a rectangle is length times width or base times height. So in this case, I'm thinking it tells me my height is 5. So I just need to multiply by the base, which is going to be this distance. I'll zoom in again, right? That distance to my function. So really, my base is going to be the function f of x. What makes this tricky is that because it says it's perpendicular to the y-axis, we're actually thinking about that we need to write this function in terms of y instead of x. So this function is f of x, so I'll write down f of x, which is e to the x minus 2. So I'll put that here, right? So f of x is e to the x minus 2. If I replace f of x with y, what we need to do first is we need to figure out what is this function written instead of y in terms of x. We need to rewrite it in terms of as x in terms of y. So if I move that 2 over, I get y plus 2 equals e to the power of x. Then if you remember from your days in pre-calc, if I take the natural log of both sides, that will allow me to move that power of x to the front. And I'm hoping you remember that the natural log of e is just 1. So rewritten as x in terms of y is x equals the natural log of y plus 2. So the way we're going to write this expression to find the volume is I'm going to write volume equals the integral, right? I should have mentioned, I'll back up for a second here. The idea is that if I find the area to find the volume, I would just integrate the area to find the volume. So what I'm doing is I'm using that area of a rectangle and I'm going to integrate that. So the idea is my limits of integration in terms of the y-axis. This point here has a y value of -1, and this origin value is a y value of 0. So the limits of integration are -1 to 0. And then I'm going to write my 5 times my height, which I rewrote as the natural log of y plus 2. And then don't forget to put dy. So this right here, if I were to find that value, would give me the volume of that solid. Okay, so that is it for the first question here on the free response questions, looking at some different opportunities for area and volume. Okay, let's do number 2. Number 2 says R is a region in the first quadrant bounded by this graph, y equals 1 over x, and a horizontal line, y equals 1, and a vertical line, x equals e. Now, I left a big gap here because I know some of you have asked in our practice with the Delta Math links, like, how will this look on the AP exam? So here's an example of a free response question where they're actually going to be giving you, they're asking you to look at an area that's bounded by some things, but they don't actually give you the figure. So you have to draw that figure. So I left this space here to kind of draw this figure. It's just a sketch, guys, so it doesn't need to be perfect. But if this is like 0, 1, and 2, and this is 1, 2, I'm going to put 3 here because I don't know if you know the approximation for E, but that's approximately 2.7183, right? That's the approximation. So I'll draw that one first. So I'm going to put at approximately 2.7183, so right here, that's x equals E. It does give us a y equals 1 horizontal line, which is here. Okay. Probably should have drawn this to be a little bit more space there. That's all right. I think we'll be okay. And then I'm going to draw this 1 over x. So 1 over 1 is 1. 1 over 2 is a half. 1 over a half would be 2. So it'll kind of look like this as you draw it. Getting closer and closer to the x-axis but never touching. So that's it. And so the idea is that we have just found that area or that region. No, we found the area yet. We found the region. I'll label it region R. So that right there is region R. So it says to find the area of that region. So the idea is when you find the area, if it's like your standard, find the area of a region, you're always trying to find the integral of the top function minus the bottom function. So in this case, to find the area, I'm thinking about my x values here. So we're starting at x equals 1, and we're going to this point here, which is x equals e. So that's 1 to e of my top function, which is y equals 1, minus my bottom function, which is 1 over x. So this is the integral that I'll be evaluating. Now, if I clean that up and rewrite it a little differently, that's going to be the integral of 1 minus, I'm going to rewrite this as x to the negative first power. And I'm ready to find the antiderivative. The antiderivative of 1 is just x. The antiderivative, I don't know if you guys remember, but the antiderivative of x to the negative first power, or 1 over x, is the natural log of x. Been a while since we've done that. And I'm going to be evaluating this at e and at 1. So if I plug in e, that's going to be e minus the natural log of e. All of that minus, plug in 1. So 1 minus the natural log of 1. So when I do that, I get e minus the natural log of e. The natural log of e is just 1, so that's e minus 1. Minus the natural log of 1 is 0, so 1 minus 0 is 1. If I do negative 1 minus 1, that's minus 2, so e minus 2 is going to be the area of region R. So that's part A for number 2. All right, part B says to find the volume of the solid generated when region R is revolved around the line y equals 1. So we're actually revolving around this line, and what you should notice is that because there's no gap, right, this is the shaded area, because there's no gap between my axis of revolution and my shaded area when I revolve it, I'm going to think that I'm doing the disk method here. And the way we did the disk method was to find the radius, all right, which is the distance from the axis of revolution to your function. So in this case, it's going to be 1 minus 1 over x, because that is my other function. Okay? Now, remember we've done this before where the area of that's going to be pi r squared. So to find, let me first find r squared. So r squared is 1 minus x to the negative first power squared. Using my understanding of expanding a binomial that's being squared, I square the first term, which is 1. I square the last term, which is the opposite of x to the negative first power raised to the second power. So I can do that math here. So the opposite of x to the negative first power squared. You're squaring negative, so it's going to be positive. And remember, a power raised to a power means you multiply. So it's going to be x to the negative second power. And the middle term is the first term times the second term times 2. So that's going to be minus 2, and then it's going to be x to the negative first power. Okay? So this right here is my radius squared. This right here is my radius squared. So I'm ready to find the volume, which is going to be pi, put that pi out front. The integral from, again, we're not changing the limits of integration. It's still 1 to e. And I'm going to write 1 minus 2x to the negative first power plus x to the negative second power dx. All right, so the idea is that I'm integrating the area, which is pi, and then this, all of that, remember all this here is r squared, and that's going to give me my volume. So if I do the antiderivative, I'll go this way. The antiderivative of 1 is just x. The antiderivative of x to the negative first power we just did in the previous question is the natural log of x. So I write the natural log of x, but remember there is a minus 2 in front. So put that minus 2 in front of the natural log of x. All right, this one's a little bit different. I'm integrating or doing the antiderivative of x to the negative second power. So if I add 1, that gives me x to the negative first power. If I were to take the derivative of that right now, I would get negative 1 x to the negative second power. But remember, I have a positive symbol in front of there, so I need to make that the opposite. All right, if you forget that, that's okay. So all of that is my antiderivative evaluated at e and at 1. So here we go. Let's plug in e first. So e minus 2 times the natural log of e minus e to the negative first power. So all of that minus, now we're going to plug in 1. 1 minus 2 times the natural log of 1 minus 1 to the negative first power. So this is going to be e. The natural log of e is 1, so that's minus 2. E to the negative first power is 1 over e minus, that's going to be the natural log of 1 is just 0, so, and 1 to the negative first power is 1 over 1, which is 1. So 1 minus 1, I should say 1 minus 0 is 1, 1 minus 1 is 0. So that's actually just going to all be 0. So my answer for the volume here is going to be e minus 2 minus 1 over e. There's no way to simplify those e's because 1 is in the numerator and 1's in the denominator. So that is our volume for part B. All right, let's do one more and then we'll be done. Number 3, we have another region that is enclosed by two functions, and it's asking for the area of R. Again, the idea is I'm thinking top minus bottom here to find the area of R. So the area is going to be the integral, right? I'm looking at these 2 points. The x values of those points is 0 to 1/2. The top function is actually the sine function, that sine wave. So that top function is the sine of pi x minus the bottom function, which is going to be 8x cubed. All right, so all of that, and don't forget the dx for your notation. So let's go ahead and do the antiderivative of that. The antiderivative of sine, I'm thinking cosine, right? Backing up. Okay, this is going to be a little tricky. We haven't done this in a while. If I were to take the derivative of cosine, right? Remember, the derivative of cosine is negative sine. I don't want a negative, so I want to make sure that I do the opposite. And then there is an argument in front of x, so I would have to do the chain rule of pi x, which is pi. You'll notice there's no pi in front of that sign, so I need to do the reciprocal of that, which is 1 over pi. So that's the antiderivative of sine of pi x. And then let's do the antiderivative of x. An x cubed would be x to the 4th power. So what number times 4 would give me 8? That would be 2. You could also think the reciprocal of 4 is 1/4. There's already an 8. 8 times 1/4 is 8 over 4, which is 2. That also works. So that's the antiderivative evaluated at 1/2 and 0 would give me the area. So let's plug in 1/2. So the opposite of 1 over pi times the cosine of pi times 1/2 minus 2 times 1/2 to the 4th power. All of that is first minus the opposite of 1 over pi times the cosine of pi times 0 minus 2 times 0 to the 4th power. Okay, so if I'm thinking here about cosine of pi times 1/2, that's really pi over 2. If you have to draw your quadrantals, you can, right? So pi over 2 is up here. That ordered pair is 0 and 1. And I want the cosine, which is 0. 0 times negative 1 over pi is 0, so that's going to be 0 minus 1/2 to the 4th power is 1/16. 2 times 1/16 is 2/16 or 1/8. Minus, this one I'm doing the cosine of pi times 0, which is cosine of 0. The ordered pair for that is 1, 0. The cosine of 0 is 1. 1 times negative 1 over pi is negative 1 over pi. And then 0 to the 4th power, all that's just 0. All right, so if I clean this up, I get negative 1/8 plus 1 over pi, which you can leave as your solution for the area of that region R. So this is going to be my area. Okay, let's do one more, then we're done. Part B, write but do not evaluate an integral expression for the volume of a solid generated when R is rotated about the horizontal line y equals 1. So let me draw the horizontal line at y equals 1. Do my best here. So there's y equals 1. And the idea is that we are revolving this region R around that. You should notice there is a gap or a space when you do revolve it. So this is going to be what we call the washer method, where we've been practicing where I want to find a capital R and a lowercase r. So the distance from the axis of revolution of 1 minus the function that is farthest away is going to be my 8x cubed function. So 1 minus 8x cubed. And then my lowercase r is 1 minus the closer function, which is the sine of pi over x, or excuse me, sine of pi x. So 1 minus the sine of pi x, put that in parentheses. Okay? And then you don't need to, if you wanted to rewrite that as negative 8x cubed plus 1 or the opposite of sine of pi x plus 1, that's fine. You can leave it like this. So when I write my volume, remember the idea is that we're going to be integrating the area. So put pi times the integral, and then I'm still doing my same x values of 0 to 1/2. So 0 to 1/2. My big R is 1 minus 8x cubed, all of that squared, minus my little r, my little radius squared, so 1 minus the sine of pi x, all of that squared, and then make sure you put one last big bracket or parentheses to put dx. So that right there is going to be my volume setup. It doesn't ask me to evaluate it, so I can just leave it like that, and we are all finished, guys. That is it for the free response questions. Don't forget, if you haven't watched the multiple choice video with all those questions, please watch that. I know I'm asking you to do work over break, but it's an AP class, and I need you guys to recognize I need to do some work on your own time. So good luck, and I'll see you soon.